In this video, we are going to talk about switch port types. And here we are going to talk about dynamic ports, and here we are going to mention Cisco's dynamic trunking protocol. We are going to talk about trunks using ISL and 802.1q. Then we are going to talk about the access ports and multi-VLAN ports. Before I start talking about these things, I'm going to go into my terminal and I'm going to show you a couple of things on one of my switches. So here I am on my Cat1. Cat1 is connected to Cat2 on port Fast Ethernet 24. Let me show you how this port operates now. It's very important to be able to see how things work on your switch. There are multiple commands that you can see this, and I'm going to show you just a couple of them. One of my favorite commands is show interface fastnet 24 switch port. So let me just type out the whole command. So it's show interface, then the interface identifier, followed by switch port. When I type this command in, what I'm going to see here is, well, many things. But let's start from the top. First thing that I'm going to see is the name of the port, and I already knew that because I typed it out here. But the next thing here tells me that this port operates as a switch port. Depending on your switch platform that you are using you using 3750, are you using 3560, are you using 6500, whatever series of Cisco switches you are using, the capabilities of ports are going to be somewhat different. But what this capability is referring to is whether this is operating as a layer 2 port or whether it's operating as a layer 3 port, a routed port. Now, if you see that switch port is enabled, and in fact, if you see any of this output on your switch, you're going to know that port is operating in layer 2 mode. Now, the next two lines here are referring to how the port is configured to operate and how it actually operates when it comes to the trunking operation on the port. We can see here that this port was configured to be dynamic auto. This is what the administrative mode here means. Administrative mode is simply what we have configured. Again, this is a very platform dependent operation. On some switches, this is going to be either a static access port or it's going to be a trunk, even though I haven't seen that particular one yet. Or it's going to be dynamic desirable, or it's going to be dynamic auto. Now, this depends on the switch platform and the iOS version that you are running. On the switch that I'm using right now, which happens to be a 3560 switch, I can see that the default configuration is to operate in dynamic auto mode. Just to prove my point, I'm just going to do show run interface fastnet 24, and you can see that I'm dealing with absolutely the default configuration on this port. I haven't configured anything yet. This port operates, is configured to be dynamic auto. So administrative mode tells me how the port is configured. The next line here, the operational mode, tells me how the port operates right now. I can see that the port now operates as a static access port. I'll explain why it operates as a static access port in just a minute. Now, the next two lines here tell me, am I going to negotiate which trunking protocol am I going to use on this port? Remember, there are two trunking protocols supported by Cisco. One is Cisco proprietary ISL, the other one is the standards-based 802.1q. Now, here I can see that the administrative trunking encapsulation is set to negotiate. What this means is that this switch will be able to operate in both modes depending on what the other switch or device on the other side asks it to do. And also here we can see that the current operational mode, or the current trunking encapsulation, is native. This native refers to the format of the frame. Recall, we have three possible formats of the frame when it comes to trunking and non-trunking. We have the native frame where we have destination address, source address, ether type, or type length, followed by payload, followed by frame check sequence, or we have ISL, which encapsulates the whole frame in ISL header and the trailer, or we have 802.1q, which inserts the tag between the ether type and the payload. So this thing here tells me that the port right now operates in a native mode. And this line here tells me that the negotiation of trunking is turned on. This tells me that on this port the DTP is running. The dynamic trunking protocol is actually operating on this port. This also tells me, this line here tells me that when this port becomes an access port, it will be an access port in VLAN number 1, which is how it operates right now. Trunking native mode, VLAN 1, here tells me what is going to be the native VLAN on 802.1q trunk should this port negotiate or become trunk when statically configured. These are all the default values. I'm going to talk about the native VLAN separately. It's a very, very interesting and complex topic, in fact. This line here, and I have to admit that this line is lying to you. This line tells me that the administrative native VLAN tagging is enabled. This is not true on this switch, but for whatever reason, there is a bug, I believe, in the software or a cosmetic error that tells me that this is turned on. Again, I will talk about the native VLAN and what this particular line means when I talk about the native VLAN separately. So for now, just believe my word that this thing here is not true. And here underneath, I have additional information about what is the voice VLAN in use, and I'm going to talk about that in a moment. And then I have a whole bunch of information about the private VLANs and other stuff that deal with mostly security settings on the ports. And I will talk about all these things, but not now. These are not basic things. We are still talking about fairly basic stuff now. So I can see that by default on my switch, the port is operating in dynamic auto mode and that it wants to negotiate the trunk encapsulation. It failed to do so, and I'm operating as an access port. But the important thing is, how can you see this information? This was one command. Another command that you can use is show interface trunk. Now, show interface trunk will show you on the switch all ports that are currently operating as trunks. And as you can see here, I have absolutely no interfaces on this switch operating as trunks right now. Yet another command that you can use is show interface status. Now, with show interface status, you're going to get an overview of the interfaces that you have on your system. So let's take a look at this part of the output here. Let's take a look at FastInternet 23, for example. I can see that this interface is disabled. It means it's shut down. And this is not the default setting, so I have done a couple of things on this switch, like shut down all the ports that I won't be using, because I really want to focus only on things that are important for this particular session here. Also, in this column here, I can see what is the VLAN that this port operates on, and I can see here that for FastInternet 23, if it becomes enabled, it will be in VLAN 1. On the other hand, our port FAST24, which is connected to another device, says here connected, and it operates in VLAN number 1. I can also see here that it operates in auto duplex mode with full duplex being negotiated, and this tells me about the speed of the port. Again, I can see the auto speed settings and that it operates at 100 megabits per second right now. And finally here, I'm told which kind of interface that is. Also, I can do show DTP. I can do show DTP interface, FastInternet 24, and I can get some more information about my negotiation of this interface. And here I can see the information, how the port is operated, how it's configured. And here I can see the negotiation status and what is actually happening. So this is some more, this command shows me some more details about the DTP. I'm going to come back to all of these things in a moment. For now, just remember that there are multiple ways you can query the information on the switch, how your ports are operating. Let's talk about dynamic ports and DTP. DTP, or Dynamic Trunking Protocol, is a Cisco proprietary protocol that switches use to negotiate trunks on links. DTP can operate, generally speaking, in two modes. It can operate in a dynamic desirable mode or dynamic auto mode. In dynamic desirable mode, switches send frames on their links indicating that they are willing to negotiate the trunk and also that they are actively negotiating the trunk. In dynamic auto mode, switches also send out frames indicating that they are willing to negotiate the trunks, but they are not actively initiating the negotiation of the trunk. But in both cases, the DTP frames are being sent out on the link. When switches agree that they are willing to negotiate the trunk and at least one of them is actively initiating the negotiation, in that case, switches are going to negotiate the type of trunk that is going to be running on the interface. On switches that support both trunking protocols, ASL and .1q, the default is that the ports on the switches are going to be in what I like to call I don't care mode, or as Cisco calls it, the negotiate mode. That means that the trunking protocol in use will be determined based on the preference of at least one of the switches on the links. That means that if one of the switches on the link is preferring ASL, then the switch that is in I don't care mode is going to operate in ASL mode. That means it is going to negotiate the ASL trunking on this link. If both switches are in I don't care mode, in that case, the fallback protocol will be ASL. If the switches don't agree on the protocol in use, in that case, they are going to fall back to being access ports because they failed to negotiate the trunking encapsulation. Also, what needs to match on the link when we are attempting to use the DTP is the VTP domain. If the VTP domain is not the same, the switches cannot negotiate the trunk and the negotiation of the trunk will fail. If the switches agree on the VTP domain, the trunking negotiation can proceed. Now, you may recall from the VTP video that we have a special case when there is no VTP domain, when VTP domain is null. This is still okay for DTP negotiations, because if DTP domain is null on both sides, it is still going to match. It is nothing. But if we set the DTP domain, we need to ensure that it needs to match on both sides of the link if we wish to use the DTP to negotiate the trunks. Upon successful negotiation of the trunk, the port is going to be in operational trunking mode. If the switches fail to negotiate the trunk on the link, the ports are going to fall back being just access ports. Now, mind you, when you do show interface switch port command, the ports that are dynamic in nature, either desirable or auto, are still going to appear as dynamic ports. There are certain features on Cisco switches that won't work on dynamic ports that require that the port is set in a static access mode. Be careful with this when you are configuring your ports and your trunks, and if you need to configure some advanced features that require DTP to be turned off. Now, DTP is on most Cisco switches in most iOS versions, is on by default. But it's on by default not only on the ports that are configured as dynamic ports. When you configure a port to be a trunk port with switch port mode trunk, it is still operating with DTP turned on. This is the equivalent of the dynamic desirable port. The only problem is that it will never fall back to being access port. That means that upon successful negotiation of trunking, this port will operate as a trunk because it is set as a trunk. But if we fail to negotiate the trunk with the other side, it means the other side is set, let's say, to be static access port. In that case, the port that is configured as a static trunk, even though it sends out DTP frames willing to negotiate, when it fails to negotiate the trunk, that means we had an unsuccessful negotiation of the trunk, it is going to fall back or remain being a trunk. This is very, very important thing to understand. DTP can be turned off on a port using several mechanisms. One is to make a port a static access port. When we make an access port using switch port mode access, the DTP is turned off. We can also, on trunk ports, use a command switch port no negotiate. This is also going to turn the DTP off. Now, I've talked about DTP in theory a little bit. Let me show you DTP in action. To do that, I'm going to set up a very simple network. I'm going to use just two switches, CAT1 and CAT2. So let me just draw them up. So this is CAT1 connected to CAT2. And on both of these switches, I will be using fast Ethernet 0/24. Also, on CAT1 here, I'm going to have a PC with Wireshark installed. This is going to be connected to fast Ethernet 03. So what I want to do here is I want to establish the connection between CAT1 and CAT2, and then I want to take the copy of these frames and send them to my Wireshark so that we can actually see what's going on. Let's go to the terminal and set this up. So going here to CAT1, I'm first going to take a look at the configuration of FastNet 24. I can see that it is operating in the default configuration, and so is FastNet 03. So I have not done any configuration on these two ports. On CAT2, this is the configuration of Fast Ethernet 24. I'm going to start by shutting down. Oops, I'm sorry about that. I was a little bit too quick. So I'm going to start by shutting down the port Fast Ethernet 24, and then I'm going to set up my span session. So I'm going to say monitor session 1 source interface Fast Ethernet 24. I'm interested in both received and transmitted frames. Then I'm going to say monitor session 1 destination interface FastNet 03, and I'm going to say encapsulation replicate to keep any tags or additional ISL encapsulation that I might see on this interface. Finally, I'm going to go to FastNet 24, and I'm going to be ready to do no shutdown on this interface. Before I do that, I'm going to go to my Wireshark, and I'm going to start the capture on my CAT1 on FastNet 03. Please observe that I have configured a display filter to capture only DTP frames. I don't care about anything else right now. So going back to my terminal, I'm going to do no shutdown on FastNet 24, and we should be seeing the interface change state to up at some point. There we go. And let's see if we are going to get any frames received on our capture port. This may take up to 30 seconds. There we go. We have some frames received. Let's take a look at these frames. Now, the first thing that I would like to show you is that this frame here was sent by a station that has the MAC address that ends with 175A9A. I don't know which frame this is, which station this is this CAT1 or CAT2, but we can easily find out. So I'm going to go to CAT1 here, and I'm going to say show interface FastNet 24 here, and I can see that this is not CAT1, but it must be CAT2. There it is, it ends with 175A9A. So we know that the other frame, so these two here, let's focus our attention on these two frames here. 0C5E9A, going back to CAT1, 0C5E9A, these are CAT1. Let's see what is happening here. I see, first of all, two frames coming from this station. Why do I see two? Well, take a look at the frame. And I'm going to put the cursor on this line here. When I go to another frame, take a look. This is an ISL frame, and this is not an ISL frame. This is the first thing that we need to know about DTP. Remember, it tries to negotiate the trunk, but it doesn't know what encapsulation is used on the other side before it hears from the other side. So, should it send a native frame or should it send ISL? Well, DTP tries to do both. It is going to send two identical frames to begin with. So it doesn't matter which one we look at, either this one, which is not ISL, or this one that is ISL. We want to take a look what is happening in the DTP frame here. As we can see, First of all, we have information about the version number. It's always going to be version 1. We have the domain. This is the VTP domain. As we can see, we are not using any VTP in this configuration. That means this string is going to be empty. Totally expected to be seen here. And here we can see the status. Now remember, DTP is a Cisco proprietary protocol. You can find some information about it if you are very, very persistent in searching, and the only detailed explanation of the fields that I found on the internet is by reading the actual Cisco's patent application. I will spare you the details there, and I'm just going to very briefly tell you a couple of things that I found out in my years of experience working with DTP, what these numbers mean. Now, if we see status that ends with 4, this means that we are in auto operational mode. Now, how do we know if we are trunking right now or not trunking? Well, take a look at this number here. It's 0x04, which means this is hexadecimal number. 0x indicates that. If we have 0 in the first 4 bits here, that means that we are not trunking. So if you see 0 followed by any number, that means we are not trunking. 4 means we are in auto mode. Here in DTP type, we have the indication which protocol we would like to use for trunking. Are we going to use ISL or .1Q? Now, remember what I told you, that this is Cisco proprietary protocol, so the best we can do here is guess, unless we have access to the source code, which unfortunately I do not have. If I see 0x40, I know, well actually I figured it out, that this should be negotiated encapsulation. So we don't care which encapsulation we are going to end up using in this point here. And finally, the neighbor field here tells me what is my MAC address. There is no need to have this information because it's also the same as the source MAC address of this frame. Now, please observe that the destination MAC address of the frame is 01000CCCCCCC, which is a Cisco proprietary multicast destination. But let's take a look at a couple of other frames. So here we have the frame again that was being sent by our cat1, and here as well. Here are a couple of frames being sent by cat2. So this is cat2, this is cat2, and as we can see, this negotiation keeps on and keeps on and keeps on, but we don't have a trunk. How do I know we don't have a trunk? Well, I'm just going to look at the last message. I'm going to look at the status, and I have 0x04. So I should know that this is not trunking. Let's take a look at our terminal. If I go to the terminal and say show interface fastnet24 switch port, this is exactly what I'm seeing. I'm seeing that I'm in administrative dynamic auto mode. This is how the port was configured. Also, I can see that I'm in operational static access mode. I'm operating, or the port, I should say, is operating as an access port. Administrative trunking encapsulation is set to negotiate, which means we don't care which one we are going to end up using if we negotiate the trunk. And we have the operational trunking encapsulation set as native, which means that we are not trunking right now. Finally, negotiation of trunking is on. Let's change things a little bit. So what I'm going to do now, I'm going to go back to my Wireshark. I'm going to restart the capture. I just want to start from scratch there. And I'm going to shut down my Fast Ethernet 24 interface. I should make sure that my Wireshark is empty. There are a couple more frames captured there, so let me restart. In terminal, I'm going to say no shutdown. No frames captured. I'm starting the interface. Well, actually, I shouldn't be doing that. I forgot to do the most important thing, and that is I'm going to change the port from switch port mode dynamic auto to switch port mode dynamic desirable. So now I should really try the no shutdown. So no shutdown here. Going to my Wireshark, let's see what happens now. Again, let's take a look at the frames being sent by our cat1. Now, please observe the status here. It's no longer 0x04, it's 0x03. Now, 3 means I want to negotiate the trunk. I want to be a trunk. It's a dynamic port that wishes to negotiate the trunk. Let's see the response that comes back from our Cat2. Actually, as it happened here, they negotiated before I was able to capture this. So let me show you the progress. So here is the ISL version of the previous frame. And here we have another frame coming from Cat1. And take a look at this one. This is coming from Cat2. Take a look at the status. It says 0x84. If you see this number 8 there, that means the trunk has been successfully negotiated. This is now the frame from Cat1. Take a look. It says status 0x83. 83 means there is a trunk. I'm still a desirable port. But which operational encapsulation are they using? Remember what I mentioned before. If you don't specify the encapsulation manually, they are going to fall back to using ISL. Let's go back to our terminal and confirm that. So I'm going to do show interface, fastnet24, switch port, and here it is. Operational trunking encapsulation is now ISL. Nothing has changed here. Administrative trunking encapsulation is still set to negotiate. It's still set to I don't care. But here we can see that the operational trunking encapsulation is ISL. So let me briefly go through a couple of scenarios of how you can negotiate the trunks, which combinations of settings will end up with a successful trunk. We have a couple possible options. We can have on one side desirable, and on the other side we can have desirable. If we have this situation, we are most likely going to end up with the trunk. This is given that the encapsulation is set to negotiate. So let's leave encapsulation to negotiate. If we have desirable and auto, we are going to end up with the trunk. If we have auto and auto, we are going to fall back to access port. So there will be no trunk there. If we have a static configuration and desirable, we are going to end up with the trunk. And if we have static configuration and auto, we are going to end up with the trunk. If we have static configuration and static configuration, we are going to end up with the trunk. Now, I should point out, or I should put some notes here, that if you have static configuration of trunks, you cannot have negotiation here. So this is incompatible here. When you're configuring static VLANs, when you're configuring static trunks, you need to set encapsulation on these ports manually. So let's now go to our terminal and prove these combinations. So I have here on my Cat1, I have dynamic desirable configured. On my Cat2, show run interface fastnet24, I have dynamic auto configured. This is the default on the switch I'm using. So we already know that this combination here, dynamic and auto, is actually going to work. So this one is okay. Let's try desirable and desirable. So going back to my terminal on Cat2, interface fastnet24, I'm going to say switch port mode dynamic desirable. Let's shut the interface down. I'm going to do no shutdown. And if I do show fastnet24 switch port when the interface comes up, I should be seeing here that the operational mode is trunk. So I can say that the desirable combination also works. Let's try auto and auto. So here I'm going to say switch port mode dynamic auto on Cat1. I'm going to say switch port mode dynamic auto. Let's do shutdown on the interface. And when the interface goes down, I'm going to do no shutdown. And I'm going to do show interface fastnet24 switch port. Now I can see that the mode is dynamic auto, but the operational mode is static access. So we can say that this behavior here has also been confirmed. But now let's take a look at these three. These three are a little bit more interesting. So I'm going to go back to cat1. I'm going to shut the interface down. I'm going to go to my Wireshark because I want to show you this particular thing. I'm going to restart my capture. And here I'm going to say switch port trunk encapsulation .1q, switch port mode trunk. So this is the configuration now on my FastInternet 24. On what am I testing now? Static and desirable on cat2. Show run interface FastInternet 24. I'm going to say switch port mode dynamic desirable. Let's go back to cat1 and I'm going to say no shutdown. Going back to my Wireshark, let's see what is happening here. Now, the first thing that I want to show you is the very first frame we captured. Take a look. It is coming from cat1, if I'm not much mistaken. Remember, it's 0C5E. So let's see, show interface FastInternet 24, 0C5E9A. So this is what I'm looking for. In my Wireshark, I can see that this frame was actually sent from my cat1. Cat1 is the side that is configured as a static trunk. So here I can see that even though I have configured the port to be static trunk, it's still sending out DTP frames. But take a look at this. Remember what I told you about the status message. I told you about the status message to look for this number 8 here. If this is number 8, that means we are operating as a trunk. So you see now what cat1 did. It claims to be trunk without negotiation. So it's never going to send out that frame claiming it's not a trunk, saying, hey, look, let's negotiate. Let's see what's going on here. Let's try to make an agreement. No, cat1 is simply saying, hey, I'm a trunk. You deal with it. Tells that to cat2. So we can see that the trunk apparently was negotiated by cat1. But what about cat2? What does cat2 say? You can see here that the status is 0x03. Now 0x0 means I'm not a trunk. Let's see subsequent messages here. Take a look at this one, for example. This is from cat2. Now it says status 0x83. What does 8 mean? It means we are a trunk. Let's confirm that. So I'm going to go to cat2, I'm going to say show interface, FastInternet 24, switch port, and here I can see it. I'm in a dynamic desirable mode, and also operational mode is now trunk. Take a look at the operational trunking encapsulation. It's .1q. It's no longer ISL. Why is it .1q? Because on cat1 here, I have set it to be .1q. So cat2 actually not only negotiated the trunk status, it actually negotiated the trunking protocol to use. So this means that we can confirm this combination as well. This worked. Let's try static and dynamic auto. To do that, I'm going to go back to my terminal, and on cat2, I'm going to shut down the interface FastInternet 24. I'm going to say switch port mode dynamic auto, and let's see the configuration. This is the configuration on FastInternet 24. Let's go to our Wireshark. I'm going to restart the capture again. Going back to the terminal, I'm going to say no shutdown, and let's see what happens on our Wireshark. Again, this is the message that was sent by our cat1. We can see nothing has changed there. Now, this is the message that was sent by cat2. Take a look at this. Status 0x84. Immediately negotiated a trunk. Remember, 4 means I'm auto, but 8 means I'm trunking. So let's go back to terminal and confirm that. Do show interface FastInternet 24 switch port. I can see administrative mode, dynamic auto, operational mode, trunk, and again, the trunking protocol was negotiated because cat1 requested the protocol to be used. So going back to our whiteboard here, we can confirm that the static and auto results in a trunk. Let's try static and static. This should be really a no-brainer because static and static should result in a trunk. But anyway, let's take a look at it. So here on cat2, I'm going to say switch port trunk encapsulation.1q, switch port mode trunk. And I'm going to say no shutdown. Before I do that, let's go back to our Wireshark, restart the capture, do no shutdown, and let's see what is happening. So this is the message coming from cat1. We can see now we are claiming to be trunk. This is the message coming from cat2. And cat2 is claiming to be the trunk. So they are still trying to negotiate, but they are both claiming to be trunks. And if I go back to my terminal, and if I take a look at switch do show interface fastnet24 switch port, I'm going to see that the administrative mode is set to trunk and operational mode is set to trunk. The reason why both of them are still sending DTP frames is because the trunking negotiation is turned on. We can turn that off. Let's give that a try. So what I'm going to do now is I'm going to shut the interface down and I'm going to say switch port no negotiate. I'm going to do that only on cat2. Again, I'm going to go to my Wireshark, restart the capture because I want to see the frames coming fresh. And I'm going to say no shutdown on cat2. Let's see what's happening in our Wireshark. Now, what I'm seeing at this moment are only the frames coming in from cat1. Remember, on cat1, I have not turned off DTP. I have turned it off only on cat2. So here I can see that cat1 is sending DTP frames and it will be sending them periodically. How often? Let's take a look at that on cat1. I'm just going to do show DTP and I will see that DTP hello packets will be sent every 30 seconds. But still no frames coming in from cat2. That is because on cat2 we have turned off our trunking negotiation. Now we can see that the trunking negotiation has been turned off. So this is it about DTP. Let's take a look at trunk ports and let's take a look at our access ports. Access ports are ports that always belong to a single VLAN. That means that when we declare a certain port to be an access port, it will not send any DTP negotiation frames. It will always operate only in that one VLAN in which it has been configured to be in. By default, all ports are going to be in VLAN number 1. Let me show you that. So I'm going to go back to my terminal and I'm going to run show run interface fastnet01, for example. You can see that fastnet01 is a port that has not been configured. That means it has only been shut down. So I'm going to bring this port up. So I'm going to say interface fastnet01 and I'm going to say no shutdown. This port is connected to my router R1. Let me briefly go to my whiteboard here and sketch this up. So I have cat1, which is connected to R1. This is fast Ethernet 01, and on R1 side, this is fast Ethernet 00. So going back to my terminal, I'm going to go to R1, and I'm going to say no shutdown there, just to bring the interface up. On cat1, if I take a look at show interface fastnet 01 switch port, what I can see here is, of course, that this interface is dynamic auto by default, right? And now it is in operational static access mode. I don't want that. I want this to be an access port. So on cat1, I'm going to go to interface fastnet 01 and I'm going to say switch port mode access. So now this port is no longer dynamic port. It will not negotiate. It is going to operate as a static access port. If I do show interface fastnet 01 switch port, now I can see that the administrative mode is access, static access, and operational mode is static access. I can still see that the administrative trunking encapsulation is set to negotiate, but there will be no negotiation. How do I know that? Because take a look at this line here. It says negotiation of trunking is off. If I take a look at the access mode VLAN, it says it's in access VLAN 1. This is the default on all Cisco switches. The default VLAN for all access ports is VLAN 1. If I take a look at the configuration of the interface, this is how it looks like. The only thing that we see is switch port mode access. If I do switch port access VLAN 1 and I repeat my show run, it's not going to show because it's the default. But if I do switch port access VLAN 10, for example, which was the VLAN that didn't exist, two things happen. First, the VLAN was created, and second, now my interface belongs to VLAN number 10. So all the traffic sent and received from this interface will belong to VLAN number 10. And this traffic will be sent without any tags, without any identification to which VLAN it belongs. Let me prove that point. So I'm going to go back to my whiteboard here, and I'm going to add another device. This is going to be my R2. R2 is going to be connected to Fast Ethernet 02 on Cat1, and here it's going to be gigabit 00. I'm also going to configure an IP address on this side. It's going to be 192.168. Let's call this 10.1, and on this side it's going to be 192.168.10.2. And I'm going to use /24 netmask here. So R1 and R2 are going to be in the same subnet in VLAN number 10. So I'm going to go to my terminal, and on R1 I'm going to say IP address 192.168.10.1. Going to configure this. On R2 interface gigabit 00. I'm going to say IP address 192.168.10.2. No shutdown. And on Cat1, I'm just going to make sure that FastEthernet 02 has the exact same configuration as FastEthernet 01 has. Also, I'm going to prepare my Wireshark. I want to see what is happening on these ports. So I'm going to monitor the traffic coming in and going out of FastEthernet 01. So here I'm going to say monitor session 1 source interface FastEthernet 01. I'm going to monitor incoming and outgoing traffic. Monitor session 1 destination interface FastEthernet 03. And again, I want to preserve any markings that exist. So here on Cat1, I also have connected to my FastEthernet 03. I have my Wireshark running. Let's go to Wireshark. I'm just going to restart the capture, and instead of capturing DTP frames, which I don't care about now, I'm just going to capture all the IP traffic. So I'm just interested in what happens between R1 and R2 when they try to ping each other, for example. So going to my R1 here, I'm going to ping 192.168.10.2. I'm going to send the ping out, and we can see that the ping was successful. Let's take a look at these frames. So this is the echo request. This is the traffic that arrived from R1. And as I can see here, I'm looking at the Ethernet frame. The only thing that I see is the destination MAC address, the source MAC address, and the type. There are no VLAN markings coming in from R1. This is the ping reply. This is the echo reply message. This is the traffic coming from R2 that went through the switch and is going towards R1. And as I can see here, again, I have only destination and the source MAC address. There was no indication on the wire going to or coming from R1 that this traffic belonged to VLAN 10. But this is VLAN 10. There is no doubt about it, because if I go back to my terminal, to Cat1, and if I do show VLAN ID 10, I can see that the traffic on ports 1 and 2 belongs to VLAN 10. And if I do show interface FastEthernet 02 switch port, I can see that all the traffic here belongs to VLAN number 10. These are the access ports. This is very, very basic. Let's now talk a little bit about the trunks. And when I talk about the trunks in this next bit, I'm going to talk and devote some time talking about the native VLAN. Trunk ports are, of course, ports that carry traffic for multiple VLANs. Now, I talked about VLANs in one of the earlier videos, so I highly recommend that you watch that one. I'm not going to spend much detail here talking about different encapsulations like ISL and .1q. I'm just going to focus on practical perspectives of configuring these on a port. Now, there are, as you know, two encapsulations, 802.1q and ISL. When we are configuring ports as trunks, we need to manually configure the encapsulation, because by default, the encapsulation is set to negotiate for use with by DTP. And since we are not going to be using DTP, we need to manually set the encapsulation. The main difference between ISL and .1q, other than one being Cisco proprietary, the other one being standards-based, the tagging versus encapsulation, is that .1q supports carrying of native frames, the frames that don't carry the information about which VLAN they belong to. And this is something that I would like to explain in a little bit more detail. So to do that, I'm going to go back to whiteboard and I'm going to change my current network configuration a little bit. Now, you may recall that this is the current network setup that we have. We have one switch, Cat1, connected to R1 and R2. What I'm going to do now is I'm going to add another switch. So this is going to be Cat1. This is going to be Cat2. And I'm still going to have R1 connected to Cat1, but I'm going to connect R2 to Cat2. This is going to be fast Ethernet 00. This is going to be this is going to be gigabit 00. This is going to be fast Ethernet 02. This is going to be fast Ethernet 01. This is going to be fast Ethernet 024, and this is going to be fast Ethernet 024. I'm also going to have that Wireshark station here connected to fast Ethernet 03. Now, what I want to do is I want to configure my fast Ethernet 024 on both sides here to be trunk. And I'm going to be using .1q encapsulation. Let's start by doing this. So I'm going to go to my terminal and I'm going to go to fast Ethernet 24. I'm going to shut it down. I'm going to say switch port trunk encapsulation .1q, switch port mode trunk, and let's see what the current configuration is. I can see that switch port trunk encapsulation .1q is set, and I have switch port mode trunk on Cat2. Oh, as it turns out, it was similar configuration, except I had switch port no negotiate. Let's add that to Cat1, even though it really won't do anything. The next thing that I want to do is I want to configure two VLANs facing R1. I'm going to have VLAN number 1, so here, or actually let's call this one VLAN 10, and I'm also going to have VLAN 20. So this is going to be VLAN 20. So I'm going to have two VLANs facing R1, and I'm going to have two of the same VLANs facing R2. So I'm going to have 10 and 20. The IP addressing scheme that I will be using in VLAN 10, it's going to be 192.168.10/24 with .1 on R1 and .2 on R2. And in VLAN 20, I will be using 192.168.20/24. Let's do that. So first thing that I'm going to do is I'm going to create VLAN 10 and VLAN 20 on my Cat1, and I'm going to repeat the same thing on Cat2. So VLAN 10 and VLAN 20. If I do show VLAN here, I should be seeing VLANs 10 and 20. If I do Cat1, do show VLAN, I should be seeing VLAN 10 and VLAN 20. You may recall the previous configuration on Cat1. So I'm going to now do default interface fast Ethernet 01 and default interface fast Ethernet 02 to remove the previous configuration. Our fast Ethernet 24 is now a trunk, and I can see that administrative mode trunk, operational mode trunk, and the information that I want to see here is which VLANs are being carried on this trunk. I can see here it says trunking VLANs enabled all. That means that all VLANs are allowed on this trunk. Going back to my whiteboard here, on my trunk, on my interface facing R1 and R2, the only thing that I want to allow are these two VLANs. I do not want to allow any other VLANs. And I also want these ports here to actually be trunks. So let's do that. Going to my terminal, on Cat1, facing R1, I'm going to start by shutting the port down. I'm going to say switch port trunk encapsulation.1q and switch port mode trunk. Then I'm going to say switch port trunk allowed VLAN, and I'm going to allow the VLANs that I care about, VLANs 10 and 20. I'm going to do no shutdown, and let's take a look at fast Ethernet 01. Here I can see that administrative mode, sorry, let me scroll up a little bit. Administrative mode, it says trunk, operational mode says trunk, administrative trunking encapsulation and the operational trunking encapsulation are both set to .1q. Also, if I take a look at the trunking VLANs enabled here, I can see that only VLANs 10 and 20 are enabled, exactly what I wanted to do. Let's do the same thing on Cat2 facing R2. So I'm going to say switch port trunk encapsulation.1q, switch port mode, trunk, switch port trunk, allowed VLAN 10 and 20. Let's do also switch port no negotiate. Let's do the same thing on Cat1, switch port no negotiate. So if I take a look at the configuration here, oops, sorry about that, I can see that this is the configuration that I have now in place. Let's do no shutdown. Finally, I want to configure R1 and R2 to be able to communicate on VLANs 10 and 20. To do that, I'm going to create sub-interfaces on R1 and R2. I need a sub-interface on R1 for VLAN 10, and I need a sub-interface on R1 for VLAN 20. I also need the same thing on R2. Let's do that. So going back to R1, the first thing that I want to take a look is the current configuration. I have an IP address configured on a physical interface, and this is not what I want. So what I'm going to do, I'm going to say no IP address. Then I'm going to say interface fastnet00, sorry, .10. I can use any sub-interface number. I'm going to say encapsulation .1q 10. I'm going to set the VLAN ID that I'm going to be using on this interface, and I'm going to say IP address 192.168.10.1, and I'm going to set the IP address. I'm going to repeat the same thing for VLAN 20 here. So now if I do show IP route connected, oops, I'm sorry, let's do just show IP route connected. I see that I have two routes in place, one on fastnet 0010 and the other one on fastnet 0020 sub-interface. Let's do the same thing on R2. And of course, I just realized that I was configuring the wrong interface. Let me explain what I did wrong here. This interface here is not actually gigabit 00. I do apologize about that. I need to make a slight correction here. This is going to be gigabit 01. I'm so sorry about that, but you know, mistakes happen from time to time. So let's just remove no interface, gigabit 0010 and 20. And I'm going to go to interface gigabit 00, and I'm going to say shutdown. Interface gigabit 01, I'm going to say no shutdown. Interface gigabit 01, 10 encapsulation.1q 10 IP address. So now I believe I have the correct configuration. You see, it just took us Just took us a couple of seconds to correct the error. So now I have this configured, and if I do show interface gigabit 01, I just want to make sure that the interface is up here, up. Let's try to ping from R1 to R2. So if I do 192.168.10.2, if I try to ping this, I can see it works, and also in VLAN 20. But let's see how this actually worked. You may recall that on Cat1, I have this monitoring session going on. I'm actually capturing the traffic going in and out of Fast Ethernet 01 on Cat1, and I'm sending it to my Wireshark station. So let's take a look at Wireshark here. I'm going to start the capture, and I'm going to repeat the ping that I just did. So I'm going to go to R1, and I'm just going to send one ping of both kinds. So this is going to VLAN 10, and this is going to VLAN 20. If I take a look at my Wireshark, I'm going to see here that for traffic going to VLAN 10, and this was the ping coming from R1, I actually have a VLAN ID. This is the traffic going back from R2 to R1 as captured on Cat1 on the port facing R1, and I can see that the VLAN tag is set to number 10. Now, this is the same thing for VLAN 20. What I can see here is that my switch is actually tagging the frames going to and from R1. Let's now add native VLAN to the mix. Back on the whiteboard here, what I'm going to do next is I'm going to turn off the span session that I configured. I'm no longer going to copy the traffic from R1 to my Wireshark. Instead, what I'm going to do is I'm going to make the interface that faces my Wireshark box a trunk as well. And I'm also going to add VLAN 20 and I'm going to add VLAN 10. But I'm going to make VLAN 10 here be the native VLAN. Now, what is native VLAN? Native VLAN is the VLAN that is untagged. All the traffic that needs to be sent out of this port on this VLAN is going to be sent without any tags. Also, any traffic that we receive on this port with no tags is going to be put automatically into this VLAN on the switch. So let me go to terminal now, and I'm going to look into the configuration of Fast Ethernet 03. As you can see, it has the default configuration. So I'm just going to turn off the monitoring. So I'm just going to say no monitor session 1. I'm going to go to Fast Ethernet 03. I'm going to say switch port trunk encapsulation.1q, switch port mode trunk. I'm going to say switch port no negotiate, and I'm going to say switch port trunk allowed VLAN 10 and 20. But I'm going to make sure that switch port trunk native VLAN is set to 10. So if I do show interface Fast Ethernet 03 switch port, this is what I should be seeing. I see that this is in administrative mode trunk and operational mode trunk. I also see that the administrative trunking encapsulation and the operational trunking encapsulation are both set to .1q. I see negotiation of trunking is off, but I see now that the trunking native mode VLAN is set to 10. That means all traffic in VLAN 10 on this port will be untagged. Let's give this a test. So what I'm going to do now is I'm going to switch to my Wireshark. I'm going to restart the capture. I'm going to go back to my terminal, and from R1 I'm going to ping a broadcast address in VLAN 10. The reason why I'm pinging a broadcast address is because I don't have any IP address assigned on my Wireshark box. That means that it will not receive any traffic by default, and it will not respond to any traffic. But if I send a broadcast, this traffic should go out of that port. Now, I see that I have received one response, and this is what I expected to see. This is from R2. Now, I'm going to repeat the same thing with the traffic in VLAN 20. Let's see in our Wireshark what happened now. So going to Wireshark here, I'm seeing a single request in VLAN 10. How do I know it's VLAN 10? Well, because I see the IP address here. Source is 192.168.10.1 and the destination is 255.255.255.255. Take a look at the Ethernet frame here. Is there any VLAN tag present? There doesn't seem to be any VLAN tag present. Also, if you take a look at this one, and this is in VLAN 20, look at this. Now we actually do have a VLAN tag present. The reason why we have the VLAN tag present here is because VLAN 20 is not a native VLAN. Let's try another thing. So I'm going to go back to terminal now, and I'm going to change Fast Ethernet 03 from .1Q to ISL. So I'm going to say switch port trunk encapsulation ISL. This is probably going to cause my interface to go down and come back up. It might not, but sometimes that happens. So I'm going to say show interface Fast Ethernet 03 switch port, and now I can see that the administrative mode is set to ISL. Let's repeat the same thing. Before I do that, I'm going to go and restart my Wireshark capture. So going to go to R1, repeat the same two commands. I should expect to get the same output here because nothing has changed between R1 and R2. But let's see if anything has changed on my Wireshark. As we can see here, now I have received two packets again, but take a look at this. This is a packet in VLAN 10. It now has an ISL header. Also, packet in VLAN 20, the frame in VLAN 20, also has an ISL header. And this is an extremely important thing to remember when dealing with trunks. Even though native VLAN is configured now on the port, I haven't changed that. This does not apply to ISL. Let me show you. So going back to Cat1 now, if I do show run interface Fast Ethernet 03, I see here switch port trunk native VLAN 10. And if I do show interface Fast Ethernet 03 switch port, I'm going to see here that it says that the trunking native VLAN is 10, but this is not true. This is not true because this applies only in a case this is a .1Q trunk. Because this is an ISL trunk, this does not apply. This applies only to .1Q traffic. Let's spend a minute more in a theoretical world. So imagine that we had a network not unlike the one that we have right now, involving Cat1, Cat2, and two devices. Let's call them again R1 and R2. Let's say that we had VLANs 10 and 20 configured just as we have right now in our network. So this is VLAN 20, and this one here is VLAN 10. Imagine then that between our Cat1 and Cat2, we had actually a trunk allowing 3 VLANs to go through. So we had our 10, 20, and let's say that we had VLAN 30 going on. On the link between R1 and Cat1, let's say that VLAN 20 is the native one. Between R2 and Cat2, let's say that VLAN 10 was native. And between Cat1 and Cat2, let's say that VLAN 30 was the native VLAN. So just to make sure that, oops, sorry about that. So this one here is VLAN 10 is native. Here we have VLAN 20 as native, and here we have VLAN 30 as native. If my R1 and R2 were properly configured for this particular configuration, as well as Cat1 and Cat2, would this work? Would I be able to communicate between R1 and R2 in VLANs 10 and 20? Just as a reminder, this is 192.168.10.0, and this one here is 192.168.20.0, and there is no IP addressing in VLAN 30. Well, let's take a look. There is one way to find out. I'm going to go to our terminal, and I'm going to create VLAN 30 here, and as well on Cat2. Then on the port facing Cat1 and Cat2, I'm going to make sure that VLAN 30 is the native VLAN. So here I'm going to say show run interface fastnet24. Just make sure that this is the case, and please take a note of this. When I added the native VLAN on Cat1, on the trunk facing Cat2, there are a couple of things that happen. Not all of these things will always happen. The highlighted line is very likely to happen, but only if the other switch is the root. This tells me that the spanning tree on this switch, on Cat1, detected a misconfiguration, and I will explain how exactly this misconfiguration was detected later on when I talk about the spanning tree, especially about per VLAN spanning tree. Even more likely message to be seen is the following error message, and this is the error message from CDP. CDP here tells me that it discovered a native VLAN mismatch between Cat1 and Cat2. Right now, I don't actually have an operational connection between Cats 1 and 2 because of the native VLAN mismatch. So I'm going to go to Cat2 here, and on interface fastnet24, I'm going to say switch port trunk native VLAN 30. If I do that, what's going to happen is that my misconfiguration is very quickly going to disappear. And if I do, for example, show spanning tree interface fastnet24, actually I don't have to do that. I can see the log messages just now. Let me scroll them up so that you can see them. Here they are. I can see that the port consistency has been restored. I will talk about this in greater detail, again, I repeat, when I talk about spanning tree. For now, let's just understand that the reason for these error messages to show up is because of the combination of the native VLAN mismatch and the per VLAN spanning tree that is in use on Cisco switches by default. So right now I have the trunk configured between Cat1 and Cat2 with the native VLAN of 30. I'm also allowing all the VLANs on this trunk. Let me go ahead and configure interface facing R1 to have switch port trunk native VLAN. What did we say we wanted to use there? What did we say we wanted to use there? I believe it was VLAN 20, correct? So I'm going to say VLAN 20 here. And on Cat2, on interface facing R2, I'm going to say switch port trunk native VLAN 10. Going to R1, my configuration now needs to change a little bit. So I'm just going to do show running config, including section T00. This will show me fastnet 00 and all the sub interfaces that I have. So what I'm going to do now is I'm going to change this sub interface here to use the native VLAN instead of tagging the traffic in VLAN 20. I'm going to do the same thing here on R2. Show run pipe section T00, actually it's T01. And in this case, I need this sub interface changed. So I'm going to change the encapsulation to use VLAN 10 as native VLAN. So I'm going to go back to my R1 and let me show you the configuration of the interface. So this is now the config that I have on R1. We can see that VLAN 20 is native. On Cat1's interface facing R1, we can see that VLAN 20 is marked as native. On Cat2 facing R2, VLAN 10 is marked as native, and on R2, show run section T01, on R2, VLAN 10 is marked as native. So if I go to R1, and I ping R2, it works. In VLAN 10, what about in VLAN 20? Even that works. So what I wanted to show you here is the fact that native VLAN is not a network-wide concept. It's actually local to the interface on which it was configured. So native VLAN applies only to this interface here or to this interface here, or to this interface here. Let's take a look at the lifetime of the packet or frame as it goes through the switch. So let's say that R1 is sending a packet. R1 is going to generate the IP packet, and then it's going to encapsulate this IP packet into a frame. This is going to be a native frame because R1 is configured to do that for VLAN 20. So this arrives on this interface here and is being sent out to Cat1. Because this is a native frame in VLAN 20, let's put 20 there somewhere. Oops, I'm sorry about that. What I want to do now actually is I want to somehow group this as a single object here. So this is arriving in VLAN 20, but it doesn't have any tag on it. This was just for us, just so that we can understand what's going on. When this arrives to Cat1, it doesn't have any markings. But when it goes to the back plane of the switch, it is actually going to get tagged. It is going to get the tag that this belongs to VLAN 20. When this now big frame, combined frame with the tag arrives to the egress port, the switch is now going to look, what is the native VLAN that we have configured on this port? And we can see that it's VLAN 30. This is not 20, so our tag on this frame remains untouched. That means that across this wire, we are going to send this frame again. This goes on the back plane of the switch of Cat2, and it arrives to the egress port here facing R2. What is the native VLAN there? It's 10, and we have tag 20 here, which means that this tag stays and this arrives to R2. R2 now is going to strip this tag and it's going to process this as a regular IP packet. Now let's see what happens on the way back from R2. R2 sends back a response to R1, generates the IP packet, tags it with VLAN 20, and this arrives to the ingress port on Cat2. Because it's tagged, it goes to the backplane of the switch, tagged just as it arrived on the ingress. Here on the trunk between Cat1 and Cat2 we have VLAN 30 as the native, which means nothing happens to this tag and this frame goes across unchanged. Now this goes to the backplane of the switch, again unchanged, and it arrives at the egress port of Cat1. Cat1 has VLAN 20 configured as native, which instructs Cat1 to actually strip this tag before sending the frame to R1. So R1 now receives a native VLAN, the native Ethernet frame with no tags, signifying that this was actually in VLAN 20. Let me show you something unusual now. So I'm going to go back to terminal and I'm going to repeat this command here to show you the configuration of a subinterface 20. I'm going to go in there and I'm going to change something. I'm going to change this to not be VLAN 20, but actually to be VLAN 2000. So this is the configuration that we have right now. R1 is now marked or configured to use VLAN 2000 as native. Let me ping R2 in VLAN 20. Take a look at this. A major success. Why is this so? Well, because when R1 actually sends this frame out, there is no indication that this is VLAN 2000. Also, when it receives the untagged frame on this interface, it's just going to internally put it to VLAN 2000, but this never ever goes out on wire. I hope now the concept of native VLAN is a little bit more clear. In the next section, I'm going to clarify, hopefully, what do we need native VLAN for? This clarification is going to come from an unusual place indeed. I'm now going to talk about multi-VLAN ports. Multi-VLAN ports are access ports that support more than one VLAN. This is very contradictory to what I said before about the access ports, how they always belong to a single VLAN? Well, there is a special use case. This special use case is when we are using IP phones. When we are using IP phones, the usual deployment is that we connect the phone to a switch and then we connect the PC to a phone. Phone is actually acting as a 3-port switch. It has one uplink, one downlink port that connects it to a PC, and one internal port that actually connects the phone logic to the network. In order to accomplish this, we can either configure an interface facing the phone as trunk and allow two VLANs there, the data VLAN and the voice VLAN, or we can use a special feature in Cisco iOS called the voice VLAN feature. The voice VLAN feature allows us to send an additional VLAN, but only one additional VLAN, to the port that is configured as an access port for a special use by Cisco phones. The good news, or the bad news, depending on your point of view, is that this feature can be configured and will work even without phone being connected to this port. Let me show you this in an example. You remember this diagram here. This is the diagram when I was showing you original configuration for the native VLAN. That is, I had Wireshark connected here to port number 3. Now, this port was configured to have VLAN 10 as the native VLAN. Let me show you this configuration again, and now I'm going to change it to use the voice VLAN feature. Let me show you that. So here is my configuration here on FastInternet 03. You can see that I have switch port trunk encapsulation ISL. Now this was wrong, so let me just change this a little bit. So switch port trunk encapsulation.1q, show run interface FastInternet 03. So this is where I actually wanted to start. So I have switch port trunk encapsulation.1q, I have native VLAN 10, and I have switch port trunk allowed VLAN 10 and 20. What I'm going to do now is I'm going to default this port. So this command default interface FastInternet 03 is going to return this port to absolutely default configuration. So this is what I'm going to end up having as the result. So I'm going to go to FastInternet 03 now, and I'm going to say switch port access VLAN 10, switch port mode access, and then I'm going to say switch port voice VLAN 20. Let me show you the output of show interface FastInternet 03 switch port. Now I have this situation. It says administrative mode static access and operational mode is static access. I have administrative trunking encapsulation set to negotiate, and I have operational trunking encapsulation set to native. This means that this port is operating as a static access port. Also, I can see that negotiation of trunking has been turned off, and I see that this port is operating in VLAN 10. But also, I have this line. It says voice VLAN is set to be 20. Now, let me go back to R1 here. And what I'm going to do is I'm going to ping 192.168.10.2 just to make sure that my communication with R2 is still operational, and this is now in place. I'm going to go to Wireshark and I'm going to restart the capture on Wireshark. Remember, Wireshark is now capturing from port FastInternet 03. It is not configured as a mirror port. I'm going to go back to terminal and I'm going to ping the broadcast address in VLAN 10. I'm getting the response. And if I go to my Wireshark, here I have 5 echo requests. Take a look at the frame headers here. Again, there is no VLAN information here. So this is going out on VLAN 10 because this is an access port in VLAN 10. Let's repeat the same thing with VLAN 20. So here are the pings, and when I go back here, I'm receiving them on this port, but take a look at this. I see now .1q tags. even though this is an access port. This is what voice VLAN does. It allows me to have an additional VLAN on an access port for the purpose of this being used by a Cisco phone or any voice over IP phone. But as you can see, now I don't have a Cisco phone connected to this port. I have something else. There is a way to prevent some other device from being connected to this port other than Cisco phone. There is a special command called interface fastnet 03 switch port voice detect Cisco phone. When I run this command, the switch is going to do its best to detect what kind of device we have on the other side. Is it a Cisco phone or is it something else? This is not a very reliable detection because right now we actually have a relatively legitimate configuration. We have a PC plugged into this port. This is the whole idea of allowing the voice VLAN to be configured. But let's see what happens if I configure this same command on, for example, a device facing a router. So here on my Cat1, I have interface fastnet 04, which is connected to R4. Let me go to R4 and just bring the interface up. And on fastnet 04, I'm going to configure the same configuration as on my fastnet 03. So to do that, I'm just going to copy-paste whatever I had configured on fastnet 03. And I'm going to do no shutdown. And let's see what happens now. The interface changed state to up. Now, if I wait a little bit, probably around 1 minute interval, to get information from CDP, from R4, I'm going to see this interface go down. So let's just wait a little bit to see if that's going to happen. And there we go. It just happened. So as you can see, if I connect some device, like for example a switch or a router, to the port that is configured to detect the failure, to detect Cisco phone on the other side, it will automatically disable this port. But on the other hand, the port that is connected to a PC, like my fastnet 03 port, is going to continue operating normally. This is to be expected, and this is just some little protection that Cisco offers to protect your network, to protect your voice VLAN from connecting rogue devices, rogue switches or routers to that VLAN.